What if a robot didn't have to turn the corner to know what's there? That's exactly what researchers at the University of Pennsylvania have pulled off with a system called HoloRadar, and it's honestly kind of mind-bending. Instead of depending on cameras, this robot uses mmWave radar, basically high-frequency radio waves, to sense its environment. Now here's the trick. Radio waves bounce off smooth surfaces like walls and floors in a very predictable way. So when the robot sends out a pulse, some signals come straight back from what's directly ahead, but others ricochet off walls, sneak around corners, and then return carrying information from places the robot can't physically see. In the past, that jumble of echoes was a nightmare to decode. It's like trying to figure out who said what in a crowded room where everyone's voice is bouncing off the walls. HoloRadar solves that with a clever combo of AI and physics. First, a neural network cleans up the raw radar data and separates it into layers. Direct reflections, single bounces, even double bounces. Think of it as sorting reflections by how many times they ping-ponged around the room. Then a physics-based model takes over and calculates where those reflections must have originated. It leans on reflection rules like Snell's law to reverse engineer the path of each signal. After that, a refinement network merges everything into a detailed 3D voxel map that labels spaces as empty or occupied by walls, objects, or even people. And this isn't just theoretical. The team tested it in real-world hallways, T-junctions, L-shapes, crossroads, across 5 different buildings and 32 different corner layouts. The robot gathered thousands of scans while moving through these spaces. When it could see the scene directly, it reconstructed it with 86% accuracy. Even when mapping areas hidden around corners, it still achieved 55% accuracy, which is a big leap compared to older systems. Where it really shines is human detection. The robot could identify a person standing behind a corner with 93% accuracy, and its position estimate was off by only about 14 centimeters on average. That's impressively tight for something working without line of sight. And it all happens in real time, updating roughly every 180 milliseconds, fast enough to react to movement as it happens. The radar runs in the 77 to 81 gigahertz band, which is already common in automotive radar. That's huge because it means there's no need for special installations or extra transmitters. You just put the robot into a building and let it move. As it rolls, it builds a deeper and deeper understanding of its surroundings. Now imagine the ripple effect. Self-driving cars getting those crucial extra seconds to respond to someone stepping out from behind a blind driveway. Search and rescue robots locating survivors in smoke-filled or collapsed buildings where cameras fail. Warehouse robots predicting when someone is about to step out from behind shelving and preventing collisions before they happen. It's not just about navigation. It's about awareness beyond line of sight. And honestly, that's the kind of upgrade that could quietly redefine how autonomous systems operate in the real world.